previously so the lock unlock values are telling state. So here whenever you are pressing the value of 1, whenever you press it means it is not sending like RK value, it is sending like ID number 123. So whenever 123 will sending the values automatically it is taking, because here I can allocate on DLC only 3.
Why only 123? Why not some other number?
Yes, you can take any numbers. Just for example, I mentioned 123. We can take the 500, 400, 456, any values we can take it. Based on the manufacturer requirement, because they allocated, the OEMs allocated some ID values for the particular values, which means easy.
So for every problem that may encounter in any vehicle,
yes,
will have some unique number.
Not like that. So in this CAD database only, not like that, because it is the all identifiers will vary, differ by their models and then differ by their OEMs. It is not a specified numbers.
Okay, where we need to check all these things?
Sorry, actually this CAN database is a confidential data. They will not provide to any test engineer, even test engineers also. So whenever they are giving the license, they will update using the screen of statement only. They are going to upload the database also. We are not able to record that also. Okay, because it is very common. So once you are getting the access of CAN database, you are able to rewrite the programming also. You can getting that access of the car also. Nowadays the cars having that card entry also. We just showing the card means also you will get the door entries. So we are able to easily access that entry, so that they will not provide CAN database for any one of the testing, even in working test engineers also they will not provide it.
Right now we are going to develop in this software this data frame.
Yes, data frame and the name. Yes. So afterwards only I am going to explain using the, we can also the database tools. Yes. Yes. Like yes.
Okay, else first you will design.
Yes, sir.
Then you will coordinate. I think that is his perception.
Initially, I told you that what we so verification and validation model. So first we need to gather requirements. Afterwards, we can do some functional designing. So based on the designing, we are going to design for the integration testing. Afterwards, we are writing some coding and we can send in the real-time values. So that is the actual BMP methods. Okay. We are just focusing on this CAN format identifier. Okay. So please all of you open that CAN EB++.
Is vector is a company, sir?
Yes, sir. Yes, sir.
Who developed that?
That's no, sir. But it is the industry, the automotive industry peak software tool. So everyone using vector tool only. In all the OEMs also. Original equipment manufacturers.
Is it a single tool or there are multiple tools available for
In vector CAN it can be defined as a different things. CAN Canalizer, CAN Open, CAN Test Studio, CAN Delta, like that. So they are using different kind of tools for different purposes. For like the analysis, people only using analyzer. So on the analyzer they are using only trace intros, the numerical view, and then the graphical view, these kind of things. The test studio they will write only for coding session. For
I'm asking, every company is using the same tool or there are any other?
No, using same tool. For that some of the logging purposes they are having some own developed tools. So logging means nothing. Whatever we can do in that or the real-time data, sir, we can store it. We can call it as a recording. So recording is called as a logging. So for that they are using some of the inbuilt tools. I think for example, I will show you the case poster. So here in this tool we are having the accessing of all the things for like analysis, order setup, design, simulation, code generation, test, and then application, and then project related things, and then one more additional tools also. Okay, so these kind of the features, all kind of the features available in this single tool. So that is the advantage of using this tool. But in the industry they are using the different kinds. For analysis they are using some CAN analyzer. For designing purpose, they are using the CAN Delta. So and then testing, code generation purpose, they are using CAN Test Studio. So and then here we are having some panels.
Connection for.
Okay, so and then we are going to do some panel simulations also. So if they are using the individual tools for that, but that brand is the vector only. So the vector only giving the individual tools, but now we are using the chosen functionalities master tool. So it is kind of accessing of all kind of operations. So that we are using this tool. So here only we are going to. So now we are going to create the database. After creating the database, we are going to upload here only. So whenever we are going to upload this database, after only we are able to work this tool, or else this is tool like just a empty box. So without database, we are not able to do anything. Initially, I told that analysis, simulation, coding, everything we need. First, initially we need to upload the database here. So our first point is that identify DLC data field. So that is enough. So for that, so please check for CAN-DB. Please open the tool. So you get the window like that. So on that, first I will move for file, create database. You just listen it after, I will give some time to again work on it. Okay. So create database. So here we have lots of templates, like we are going to create the CAN, FlexRay, Ethernet, J19, J9, J50, J7. So lots of templates we are able to create using this vector tool. Okay. So what are the protocols available in the automotive industry? We are able to create the database, which means functional design for this. So here I am selected only CAN template.dbc. So CAN template.dbc is nothing but so dbc called as a database container, or else db database CAN. We can call as a database container, or else db CAN. So this file can store as the file type of dbc file. So .dbc file only will be going to save on it. So then initially you asking for the MDC, sir. So the MDC is nothing but the multi-network database. Okay, so in the MDC file we can store as a multi-network collection of FlexRay, Ethernet, J19, that these kind of things we can do. But here we are going to work for CAN template. So one more template is a CAN FD template. So CAN FD template it is for the full of extended format only. So we are not able to work for CAN FD. We are just going for CAN classical CAN we are going to use.
What is .dbc stand for?
So DBC stands for database container or database CAN. Okay, I just give it and then create one file name, then the locations. So here I just create the database for DVRIP. So once we have created the database means so once we have created the database means we will get the let's say TSL network, easy use, network nodes, messages and then signals. So it is we are going to work for the signals. We are going to create collection of signals. The signals going to map it for that layout allocation for the messages. So the messages we are going to map it like who is the transmitter for that message, who is the receiver for that message. So this is the concept of function design in our CAN database. So the network is nothing but the collection of network, it means nodes, messages, signal is called as a network. So the entire thing we can call as a network. So the single network consists of nodes, messages and then signals. So the ECUs are nothing but whatever we have created the nodes, it is directly updated on ECUs. The initially I mentioned the ECUs and nodes are same. So we need to edit, if you want any editable purpose means we are able to edit in nodes. So that is directly updated on the ECUs. Okay. So both are same.
So we cannot change anything on the ECU.
We are not able to edit in ECU.
We can change in
Only network nodes.
Because ECU is the controller.
Yes, electronic control unit. So the ECU stands for an electronic control unit. So in our field we can call as a node. So we can edit something or else we can changing some mapping or receiving a transmission data action mapping means we can do it in our electronic nodes. That nodes will be automatically updated on the ECUs. Okay. So here I can go with an example of remote keyless entry. So remote keyless entry we can call as a RKE. So the concept of remote keyless entry is we can open the door using the key fob. So that previously we were using the door keys, so we can put it in the key and then open the solenoid, open the door. Instead of that, now we are all the cars having the button opens, like means key fob. We can 4 to 5 meters of range. We can lock the car, unlock the car, open the tailgate also. So that's a concept we have planned to explain now. So for the example, I can take the RKE. So the two nodes we have here. So one is going to transmit, one is going to receive. So the RKE is the transmitter. Whenever pressing the button, so based on the button values, the receiver and is a body control module. They can call as a BCM, body control module. Body control module unit. Unit means nothing but ECU. Already I mentioned different kind of ECUs in our car. Engine ECU, transmission ECU, same like that. The body control. The body control module consists of all the outer surface of the electronic communications, like our indicators, buzzers, inbuilt flashes, so headlamp, and then wiper controls. So these kind of the outputs and the inputs comes under the body control module ECUs. So BCM ECU and then one more RKE ECU. So here this ECU able to transmit some values. So what are the values means? Lock value, unlock value, tailgate. So this is initially I showed the working of ECUs based on the sensors. Digital or analog inputs. The output, the working of ECUs will be taking the decision. So after the actuators will be executed. So here the DC is going to act as an actuators. So based on this digital or analog values, the sensors will be going to, actuators will be work on it. In between that, we are having the CAN communication. So with the help of CAN communication, they are going to take the input value as a digital and then setting the output for the actuator. So it is the actual scenario. So in this RKE, we have the 3 signals: lock, unlock, and then tailgate. But that button able to sending the only 2 values. Whenever we have pressed, the value is 1, or else the value is 0. We are not able to transmit more than 1 or 0. So here we can set the value as 0 or 1. So it will be occupied the space of only 1 bit. For 0 means we can take the 1 bit. So 2 power 1 value is 2 power 0. We can start with 2 power 0. So we can take as only 1 bit. Same unlock button also doing the same 0 1. So for all the values we can take as 1 bit. So totally it will be occupied 3 bits. For RKE ECU, we can take as 3 bits of values. We can store it 0 1 0 1 0 total 6 values. We can take as 3 bit. So for this collection of signals, we can say it is RKE ECU ECU. Before that, we have some standardized format, CAN frame format. We need to set the identifier, we need to set the DMC, we need to set the data. So for that, collection of this one. So lock, unlock, tailgate. We can map as a ID number 0x400. I can give the ID number as 400. We can give the any numbers as per the OEM's requirement. Just now for the example, I can give the ID number 400. So this ID number 400 will collect the value of lock to unlock tailgate. So here we are going to setting as a TX as RKE ECU, and then it will be received by the BCM. Okay, so this is what we are going to do in this tool. So first we are going to create the lock unlock tailgate. So
lock unlock both are pointing to same thing. Like if one is 1, another one will become 0.
yes. But
by lock we have 0 and 1, by unlock also we have 0 and 1.
yes, because that is what that in the last sequence functions we have checked. So whenever you press the unlock button, the doors the condition will be checking the doors are locked or not. The doors are locked or not. Previously we write the program like so unlock button means it's checking if FL and F4 and something. So if it is locked means the doors are already doors are in unlock condition. Like that we wrote the code yesterday.
Are asking the questions. For example, we have
It is our button. 2 buttons ఉంటాయి. ఒక బటన్ లాక్ చేస్తుంది, ఒక బటన్ అన్లాక్ చేస్తుంది. కానీ ఇప్పుడు ఒకటి ప్రెస్ చేస్తే సార్ దాంట్లో ఇంకోసారి ప్రెస్ చేస్తే అన్నట్లు ఉండదు. అర్థమైందా?
మనకు కావాలంటే పెట్టుకోవచ్చు.
It is what we only one button is alpha here. First time is specifics long. Second time is specifics unlocked. Here the one button is.
Why we are wasting 2 more bits?
Why you wasted a bit?
Here I have mentioned only 3 functions only, lock, unlock, delete. But the functions having the another function. So whenever you holding the unlock button for more than 3 seconds, it will be giving the search alarm of your bar, which means your all indicators will be blinking for 30 seconds. So our car having another features. So that RK key fob having nearly 10 to 12 features. So here I have mentioned only 3, lock, unlock, delete. So if you have pressed the lock button, when inside of the the key is at the ignition switch. So after that you have pressed the unlock button for 3 seconds means it will be giving the panic alarm.
Okay.
Whenever you are inside of the car, which means your body door system having the malfunction, unable to open the car. At the time you need to indicate you are in the panic situation to the outside of the vehicles. So ignition switch on. At the time you have pressed and hold the unlock button for 3 seconds. It will be the panic alarm. The buzzer will be continuously enabled. So whenever we are open the door, after that time it will be going to off.
So when single button has multiple
Options.
functionalities, for single click one functionality, for double click one functionality, for long press another functionality, like that, then we should have how many functionalities you have, that many internal bits you should have. Yeah.
No, sir. That for example, we need to check the long press conditions. Means we need another signal value. That the ignition switch. It is on or off conditions. So that value, that are the things we are going to write in the capital scripting. If I can take the long press values, that values means it is more complicated now. It is not for understanding. So now it is means you just understanding the 0 1. It will be generate the value of 0 1. It will be generate the value of 0 1. We can mapping it. That is fine thing. So for that condition, the futures we have more than that long press ignition switch means we can take the help of one more system, that transmission control unit. So gear is enabled or not, which means it is the which gear, first gear, second gear, or reverse parking gear, or it is the neutral mode. That kind of things we can collect it. Afterwards, ignition values we need to collect it. Afterwards, take the help of RK key for values we can collect it. So on that we will write the code like if ignition switch is equal to 0 to 1 and unlock button is equal to 1 and the gear value is equal to what's the value of function. Based on that, we have writing the signal values that the big function will be enabled, so the indication will be enabled like that we are writing the code. So the collection of signal values, it is a more work. So initially we are going to just design the function now. So we can take the these 3 functions, lock, unlock, delete. Okay, so the point is we are going to create we are going to create the lock value, unlock value, tailgate value. So as per our requirement, I told that the lock value is only 0 1. So unlock is 0 1, tailgate is 0 1. But based on the requirement value, it will be changed as 0 1 2 3 also. Okay, because if you can add that unlock button means press and hold for 3 seconds, it will be generate one more values. 0 1 2 also we can take it like that. So just we can take this 0 1. So we have created the signals and we have mapped into the ID number 400. So the 400 going to map as a RP is a transmitter and then the PCM is a receiver. Okay. So for that initially we needed 2 ECUs. So for that ECU we have created the network node. Just click on the network nodes. So if you have clicked this means the panel will be like that, name address command. Or else you just right click here, giving a new. So it will be open that definition of the node, which means which node you are going to create. So name I have created as a
Node is ECU.
ECU.
We are at the ECU only.
What sir?
We are at the ECU only. Again, network nodes.
Sir, we are going to work on network nodes only. Don't touch the column of ECUs. So network columns you don't need to touch it. For our entire purposes, signal, messages and network node.
First you create. Okay.
Yes sir. Once I have created this, afterwards I will give some time to you can click. Okay? So now I have created the RKE ECU. Okay, so it is like assume it is RKE ECU. So what are the signals we are going to map in for? What are the signals it is going to transmission, and then what are the signals going for the receiving. So that is called the mapped RX and then mapped TX signals.
Address we didn't mention.
No need, sir. Address no need. So what are the you created, we can able to change the 0, 1, 2, 3. So the ECU address is not an issue. Okay, apply and then OK means. So now the RKE node created. So one more part we need for the receiver element, body component. So right click. So right click on this column, right click and then give new means you will get the same. Again I have changed as a BCE. Okay. So it is like now we have created the two ECUs. For these ECUs we need a signals and messages. So already I told you. So whatever you have created the same we can see in that ECUs also.
ECU will display all the ECUs that you have created.
Yes.
Under network nodes.
Now you can see here. So what are the things we are going to edit here? We are need to update on network nodes. That is directly application on the ECUs also. Okay. Okay. So if you have opened this means it is showing like what are the TX messages, what are the RX messages. So what are the signals it's carrying, TX signals, RX signals. So it is the concept of the ECU. So if you can take one ECU means it is mostly about the four concepts. What are the signals you map for receiving and then transmission, and what are the message IDs, that is the RX messages, what are the TX messages. Okay. So as of now we can just talk on this. So next we are going for the signals. So signals means nothing but a lock unlock failure. So what are the things giving the values, we can call it as signals. So now the ultrasonic sensor giving the value, so we can call it as the ultrasonic sensor signal value. So radar sensor giving the value, radar sensor signal value. ABS malfunction, it is a ABS malfunction signal value. So what are the values we will get it and then we are going to set it, that is called as a signals here.
Signal we can think as a sensor value, sir.
Sensor values, like inputs and then outputs. Okay, so going to signals here. So whenever you can press the, you can note down here that name address command will be there, and then whenever you press the signals, you will get the name, length, byte order, value, these kind of things. Okay. So here I can give the right click and then open the new. So here it will ask the definition of the signal. So here I can say first one is lock. So and then length bit we need to set it. For lock, here we are constant default value that is a 8 bit. It is appearing like a 1 byte of values. Okay, just I can give the calculate minimum maximum. It is showing minus 128 to 127. So for is the value type of signed. So if you go changing the unsigned means the values we can start from only positive values 0 to 255 we can take. So as per our record, suppose we are using some temperature sensor values means we can take the minus values also. So on that time we can change the signal type. So now we need only value of 0 and 1.
We know sign and sign.
Yes.
We don't know about the cyclically float and double.
I
So we float data type.
slow data type and then double, but it's having some conditions also. Even I am also not working on IEEE float and double. Okay, we are only working with the signed and unsigned. As of now, we are not working with the IEEE and float and double. Even for CAN messages, it is no name. Okay, so we are set unsigned.
It is taking for IEEE float 32 bit default. For double it is taking 64 bit.
Oh, okay.
And in C programming we don't have that much length here actually.
Yes. Okay, so the next one we are going to set it is just 1 bit value. So after 1 bit we can give the target maximum 0 and 1. So now what we are going to say means the definition of the lock signal, we are not able to generate the value more than 1. We can generate the value 0 and 1. So what are the values we can set it here? This is the base for our testing. Suppose we have created 8 bit values means we can generate more than 1 values. So at that time we will face some issues on our writing program. So in the Kappa scripting, if it is using value of 2 means we will get the error because we are facing the values of only 1. 0 and 1 only we are writing because on that we are not using any condition if it is greater than or equal to 0, greater than or equal to not like that. We can just accessing the signal of log, just accessing the signal of unlock. What's the value we will get it, we can use it like that. Okay. So and then unit of water we need, for example vehicles between kilometer per hour. For now we are using Boolean values, so we can just choose some Boolean. Okay. So the factors, the factor is in the another concept. It is will explain the vehicle speed. Okay, so now it is no need because what are the values we have designed here? It will be multiplied with our value of increment 1, 2, 3 means it is incremented as a 0, 1. If you have increment giving the value as a 0.25 means. So it can be giving the values that starts with 0.25. So afterwards, if you can increase the length a bit, you will getting the multiplications of the value. First value 0.25, second value 0.50, third value 0.75, like that. So now here it is no needed for the vehicle speed. You will take that.
So the factor is a multiple of the length.
So based on our calculations, ma'am, it is suppose if you have exceeding bit, for example, RPM we have up to 10,000 of RPM, but we are going to take only 8 bits. But the 8 bit is not sufficient for RPM. You can check this. 8 bit. So the value maximum will be generated to 55, but we need to compress 10,000 into the 8 bits of range. So on that we are using this some calculation. For example, 10,000 RPM we need divisible by, so maximum is up to 55. So we will get the 10,000 of values, but we compress in the 8 bit of range. So the values will not increase as a 1, 2, 3. It will increase as a 39.2 as a first value. Second value it will be increase as price of the 39 based on it. So what are the values? Because we are not going to work with more than 8 bits, which means more than 1 bit of value, so that we can compress the values with the help of factors.
But whenever you are placing a point calculate
82.
Because it is a 8 bit range. There I mentioned 8 bit.
you keep 32 bit. That's how the values will be changed.
So what are the ranges we have increased here? We will face the issues and the arrangement of layout in the CAN series. Okay, so that example also I will show you. So if we can use the more than 8 bit means what the issues we will face in the coding time also. Here you can say that just using the 1. Okay, so that is enough. So the value type is nothing but we can do the values for the each 0 and then 1 also. So for example, 0 means the doors are closed, 1 means the doors are opened. In our analysis tool we are having command section also. On the command section we will get the output that what are the values occurred based on the value will be showing some string values. That is the doors are locked, doors are closed like that.
So here we don't need to mention this value.
No need, sir.
No, actually somewhere they should be mentioned so that they should pop up here.
So
Then you need to select from the pop-up list.
yes. Else I will explain that how to create the value table also I will explain.
Okay.
Because these are advanced existing advanced features for us, not a mandatory. Okay, apply okay. So now we have created the.
What happens if you press directly OK without applying?
That is not an issue. Just they are giving the apply concept also. We can directly do OK also not an issue.
I think there might be some difference. Nothing.
So if giving the
How
OK.
you change them if you press for OK button, it's not changing. When you change this value, then you press OK.
So let us say the So if we can take that OK, it will directly it will take the help of apply and then OK. Okay, so now we can take the 1 and then we will the values will be changed as a little bit of 1. So the value type constant, initial values is 0, factor offset, minimum 0, maximum 1, unique unit type. So value table we mentioned means we will get the value table also. So the command we need means we can add this signal is created for the RTA purpose. So same way that we have created for again for another. So then don't using space on that name column. So instead of using underscore, so if you using the space at the means I will do that. So now we have created the three signals.
If you don't provide anything, unit value.
And there is not an issue. So here mandatory thing is a little bit of minimum maximum value factors and then offset also. So the offset I will explain the one more signal value. So here no need of offset. So now we have created the three signals. So now we need to map the three signals as one ID number. The ID number is a 400 we have mentioned. So the ID is called as a can frame or can messages. So now we are going to can message, the message column. So just take the message and then we will see the format, the name, ID format, DLC, like that. So right click on open new. So now we have to get the definition for the messages. So here I can say that the messages is the RKE_1, which means we are going to create the RKE message. But this name is not a specific thing, we can give any name, but the identifier is the important thing. So for our confirmation only we are creating the name as the RKE1, but we can give anything. For the ID number is the main, so ID number we can use 0x400. Okay?
What is the purpose of this message?
Sir, this is what I have explained in our PPT. So this is the identifier now we are creating. Okay. So this is the identifier based on the, because what's the ID you have given it, based on that ID whenever we are going to transmission, the operation will get some priority. So based on the ID. So now we are going to get multiple IDs, 400, 500, 300, 120. So nearly 20 messages we are going to create now. Okay. So after creation we are going to upload the same on our test tool, case master tool. So at the time we will get the transmission. So we need to transmit 500, ID number 400. So who will get the arbitration? So that is the point here we mentioned.
So for example, you have the airbags and you have a tire punch or you have a AC signal. Out of three, which is the more important, most priority for safety? Airbags. So for the airbags, we are giving a least ID. So that least ID is going to send the first to the true identifier. So that is executed so that the airbags will be activated. Later the next ID is going to activate. And the next ID will be activated.
Okay, so ID number we have mentioned the 0x400 that I mentioned here 0x400. So we can take the type can standard or extra type. We are going to also that can standard. So you have no need to change this type. So whenever you can open defaultly it will be shown like a standard. Because initially you open the can template only, so that it is showing the can standard. So here you have no need to check anything. So next you go into the signals column. So in
If I
this
instead of 400, if I give 40, does it accept?
yes, you can give 40. But our common database I will using some of the common values, which means as per requirement using some of the PDFs documents and creating some database. Based on that, I am assuming some lowest number of values. So, but what are the values we created? We need to create all the people as the same values. That's the main thing. Or else we will get the different kind of outputs. Okay. So after creating that one, we can give the apply and then OK also fine. So now it is just a empty message. The ID number 400 is just an empty message. We are not mapping any signal values here. So for that we have the file and then the option is the consistency check.
Just go back once. After creating the signal.
After creating the signals,
Message.
we are going to messages.
Yes, the message.
So in the messages, we just create the message ID only, which means RK1 standard can 400. That's the default ADDLC will be there. Okay. So after that, we are going to take the help of consistency check.
Okay, apply.
Sir?
Okay.
Apply or okay anything you can use. So now go to consistency check. Here we will be having more errors. So if you are not mapping anything properly, it is showing the consistency check. So this tool advantage is that the help of this consistency check we are able to easily mapping signal, messages and then easily mapping also. Okay, so first error we can see.
Can you give where is the consistency?
Now go to file.
Fine.
Yes.
Okay.
So this is our page. Go to file, top left. So and then that one consistency check. Before execute this script, consistency check we have it open. That means we will get this kind of errors. We are not mapping anything. So just you can double click it. First one is there, next double click it. Info that no sender node. For that object status of RK message. For that message you are mapping any sender node. So that is what we need to rectify this. So and then log signal. So here it is mentioned signal not mapped on message. So we need to map in this message on any one of the signal, not the particular thing, but we have a requirement as a 400. So we need to map. The same thing we have it for the all signals. Okay, signal not mapped on message, the signal not mapped on message, no sender. So now we are going to rectify this. First we need to map in the signal on message. Just give the text mark and then go to our column. So again double click on this RKE message, we will get the edit option, or else just right click on this, we will get the edit message. You can open it. So go to the signals option. So here we have the option of add. So what are the signals you need to add in this particular message? In the top or bottom, top left bottom you have the option as a add. So you can give the adder. So what are the signals you have created in the signal column? Everything will be shown here. Okay. So here we need to add the 3 signals. So I can drag all the signals, or else you can select one by one. That is not an issue. If you give the OK means if the now the signals are showing here. So lock, tailgate, and both are all the 3 are now mapped on this ID number 400. Now we can give the apply. Now it is asking for do you want to give the setting and adjust the DLC, which means based on the signal values. Now we can allocate only 3 bits of values, but we are initially defaultly taking the 8 bytes. So it is asking for we can adjust the value based on your stored data. So we can give the yes means it will be storing. Now where we can check means going to this layout. After signals we are having transmit receive, it is a receiver ECU. Third one we have the layout. So this is the control, data field column. So here only we are going to store our entire data. We are having this message up to 64 bits. So from 0 bit to up to 64 bit values we are able to store the single message. So here we are using only 3 bits. So based on that now I am going to check the definition. Okay, once we can do the apply.
Sir, can you repeat this only message that you want to say?
Yes, sir. So I just delete this message and then again I will delete it. Okay. So as of now we have created the lock, unlock and then tailgate signals. So after that we can create the message. Go into message column, right click, give new, and then we can create the ID number messages are OK_1. So ID number is 400. So you can directly add the signal also, not an issue. Okay. So but initially what I explained, first create the message and then give OK, like that I mentioned there. But we are able to directly apply on it. So and then go to definitions of the RK1 and then go to signals. Here it will be asking the top left to bottom, we having the add and the remove some signals. So we can give the add value and then using, so these 3 signals we need to mapping for the ID number 400. Okay. So the signal is not only for the particular message, because the ultrasonic sensor is used for ADAS ECU and then RPAS ECU, some of the monitoring purposes also. It will be taken for 3 ECUs. So we can use the signal values for any ECUs, there is not an issue. Okay. So just now I have created adding the clock to using the control button, unlock tailgate. So then okay. So now 3 signals are added here. You can check here. 3 signals are added here. And then give apply means it will be okay. So now you can double click. So now you can see that DLs will be automatically adjusted. The value is not because the 3 bits value compressed under 1 byte of it. So now we can go to check signals and the transmitter receiver we are not mapped, it will be empty column. So next we go to layout. So the layout now it is arranged as just 1 byte values. So first bit, second bit and then third bit. So instead of that we can drag and remove the values also. For example, I just click and doing the left click and drag on the some of the places. So now I have allocated the unlock as a 8th byte of the we can able to change the location also. It is not an issue, but inside of the 8 byte we can move it anywhere.
So exactly if I do,
What's that?
suppose the signal I send to the first bit and 0 bit and third bit I send to the
So instead of like that, does it? Yes. So now it is called as a overlapping. So now I can give this just I give apply and then OK. So now we are going to check the file consistency check. It is showing that invalid offset and then overlapping with the message of RK showing the error. So warning invalid offset means nothing but the start bits of the first bit, second bit, third bit. So it is a overlapping error. So we are not able to do like this. So in the first case, in our editable purpose, it is overlapped means we can check in the consistency check, we can clear it.
Where you are, how you are getting this information?
So going to that file top left file, so we have the option consistency check. So once open the consistency check, so what are the errors we did during the creation of the database, we will see here. Okay. So just I will open and then open the layout and I just move the signal values. Okay. So instead of that, I will arrange the signal as an individual byte. So first byte for top, second byte for unlock, third byte for tail bit.
What are these apps arrange to front to back
It is nothing but here it's showing that the value starts from the 0 to 7th bit and 0 to first bit now. So it is like if you can the this means it is automatically defaultly arranged the default values. In the first bit it will be changing the value first bit. So it is a bit indexing, but that means nothing but here it's showing that it starts from 0, 1, 2, 3 like that. So for us it is using like that. It is easy to mapping the values. Apply. So and then give OK. So as of now we have created the signals and we have mapped with the message ID of 400. So in the 400 message we are getting up to 8 DLC, but we have created as a definition of 400 we created only 3 DLC. So now you can write a program like for accessing a 400 DLC of first bit means for accessing signal lock, second bit for accessing signal unlock, third bit for accessing signal tail bit. Now we can easily write the program.
Byte real.
Yes. So that I did the structure concept in our C programming. So in our going to write the program for this Arduino on the ECUs, we will create the ID. We are going to using the real-time transmission now. So create ID number 400 and then mention DLC as 3. So on the DLC we are using the array concept. So array of 1 is a lock, array of 2 is unlock, array of 3 is a tail. Now you will not get any confusions. If you work with the real-time concept, you will not get any confusions.
Others we have like single layer with one bit to bit.
Yes sir, that is comes under the loop mode. So it is can yes sir, we have the set bit rate, set loop mode, this kind of options here. But we are using the set bit rate is for easy for understanding. Loop mode is a little bit complicated compared to
If you use like this bytes unnecessarily, we are using 3 bytes. No message we are using. That is not a problem.
not a problem because we are having accessing of each message as a file up to 8 bits now. So in built of that 8 bits we can use any values.
So each functions we use.
Yes.
Yes. Is going to be
Yes. For each ID carries the 8 functions. Okay. So up to now, is it clear?
you are going to install it.
No. So afterwards now we are going to map it for easy. Just now we have created the ID number on
Just
the
before you install it, TDC.
Yes.
Yes, you use it. Complete process.
Okay. So that now it's a team break down.
If it is not over, we will go for the started.
we actually complemented
Okay. So as of now, we have created the signal values. So we have mapped this ID as ID number 400. Now we are going to set this TX concept and then RX concept. So we are going to map it for RK, and then BCA. So if we have mapped means that is the fine thing. So we have created a signal.
Now we kept in messages only RT messages.
Yes.
BMA messages we are not.
No. BCM we don't want any message because
Because of the byte.
audio is going to just receive the value.
It's only to transfer the data.
So in the BCM message we will create for the actuators. Okay, the BCM. So whenever it is receiving a floor value 1 means we are actually condition we need to create, but just give the input values only. So actually it is for to create. If you can really real time connected with the actual this means for that no need of messages. Sorry, on the terms we need message. No need of database values. Okay. So the next concept is going to network nodes. So in the network
We do this later.
no sir. It is just a simple thing only. Just you can add the signal and then add the RX. Because once we have mapping this ECU means that is the completion of the creation of a database. So just to give the overview, we have created the signals. So these 3 signals have a limit of 1 and then we are moving to the RPA message. We have created ID number 400. So under the ID number 400 we have added 3 signals. We have checking the layout and then adding the layout as per our requirement. So now we are going to set this transmitter and then receiver ECU. Okay, so transmitter we can directly add it on the message. So we have got the add option. So also we can do going to the network nodes. Going to network nodes already we have added 2 ECU. So one as a transmitter, one as a receiver ECU. Okay, so now we are setting as a RP as a transmitter. So just double click means opening or else right click edit mode. So now we are getting the definition of RP map to the TX signal, map to RX signal. So what are the signals we are going to map in for the TX, what are the signals we are going to map in for the RX. So this is going to justify for the transmission. Correct? TX means we can directly repeat the TX messages. We are not able to mention the individual signal. So that's the thing. You have the signal of log and log KA, but you are not directly accessing only log 2 or KA. So we need to get the access of 400, message 400. So that is what we have mentioned. TX messages. Okay. So this TX messages just click the add. So add means what are the messages you have created in the message column, it will be shown. Okay. So you just click OK. So now the messages are added. Okay, message. The ID number 400. And then I standard format.
Layout.
Okay.
Can you repeat sir?
Yes. I just give the candidate. Okay, so after completion of the messages, going to the nodes. So now we need to set who is the transmitter, who is the receiver. So as of our knowledge, the transmitter is RKE. So just to open the RKE, we are having the different kind of definitions: mapped TX signal, mapped RX signal, TX messages. So what are the signals mapping for the different different directions? So now we have selected the TX messages for transmission. We are not individually selecting the signal here. So go to select the messages, transmit the messages. So give the TX messages, give add value. So and then what are the messages you have created in the message column? As of now we have created only 1 messages. But then after we have created more than one, like 20 messages we will create. So on that we need to select the particular message, ID number 400. So and then give OK means it is showing the message values. ID number 400 standard format, it's having the 3 DLC of values. And then now you have to give the update. Now you can check in the mapped TX signal. So now these are the signals are mapped as a TX in our RK ECU. Okay. So just click OK. So now you have set RK ECU ID number 400 as a transmitter ECU. Yes. So now you can check the CAN messages. So go to double click and then now you can check the transmitters. Now you will be shown. So the signal always mentions the network nodes. Okay. So now the transmitter ECU is the RK ECU here. So now we need to check for the receiver interface. So going to network nodes, the receiver is a body control module. So right click. So it is a receiver signal, not the RX signal. So in this way we are able to add individual signal also apart from all messages. For example, now RP is going to receive by body control model all the signals. Lock and lock period, these 3 signals are accessing the entire body of the car only. But some of the times, different transmission controls are ending the values of gear shift values, vehicle speed values, some of the shaft values. But in our instrumental cluster, we need only the vehicle speed value. So on the time particularly you pin particular signals only. So that is what here mentioned. Add individual signals. Add all from one messages. If you are accessing of all signals from 4 means you can give this. Else I want only a particular signal means we can give it as a add individual signals. What are the signals based on?
Will there be any performance issues, sir,
So
in both the depths?
no.
Adding one signal and adding many signals.
It is like easy for mapping, sir. For example, here if I add individual signal means I need to select one and then one like that. If you are adding that add from one message means now I can keep the entire message. So this message consists of 3 signals only. So directly to be added. Just now I give the message. Click OK. So automatically 3 signals are mapped here. So we no need to select individual signals. But in the sum of the messages, we don't want all the signals. So at that time we will select the particular signals. Okay, sir. So now give the apply and then OK. So now we have created one database for the transmission of the 2 ECUs, one for RTA, one for PCM. So now we have uploaded means uploaded this to TS master. We are able to transmit ID number 400 and we can checking the some performance and statistics and then graphical view, numerical view, cages view, and we can do some simulation LED indications. So and then I am using some logics. So using this database only we are able to do. But now we have created only the ID number of 400. But we need to create up to 20 messages, which means 20 IDs.
Created any database,
Sir?
we have not created any database, right?
Right now we have not created. Afterwards I will give some, so we can take this entire day. So this whole day I will already provided some documents in our Karita Acharya portal. So on that I will give a signal also. So I will explain how to we can create the signals using that documents also. So now we can go to file, top of the file, consistency check. So now this column will be empty. So whenever we get this column as empty, we will get the proper CAN database. Okay.
Consistency check possible.
Sir?
Any error is the
Consistency check will show the what's the error.
You can take the 5 minutes and then come back. Yes, sir. Yes, sir.
You shall start.
Right.
ఇది ఇక్కడే ఉంటే అంతా ఇంగ్లీష్
Yes, continue.
Yes.
అది మళ్ళీ అంత పడుతుంది.
Yes, sir.
ఓకే
Okay. So now we have created some signals mapped by the ID numbers, and then we have arranged some layout, and then we have mapped by transmitter issues and then receiver issues with the help of consistency check. Okay. So the some of the small shortcuts I will explain for development. So create database. So I will explain the initial step. So create database, you can select the CAN template.dbc. Okay. So for this point, please note it because I don't have any reference document for this, not like step by step. So now I will do a slow phase there. So initially give create database and then select CAN template.dbc, not FD, CAN template.dbc. Okay. So afterwards give OK and then you can create the file name and then path location. So all of you commonly you can save as a DVR ID. So you will save as a sample, you can save as a DVR ID. So after creating the template, you will get the output like a networks, easy use, network nodes, messages and then signals. So this is the common UA display in our creation of database. Okay. So we can move with that network nodes, messages, signals. So as per our requirement, what are the network nodes we need? So for each I will provide you one transmitter and one receiver node, or else one transmitter node I will give you 5 or 3 or 6 receiver nodes, because one signal is able to receive by one fellows or else one or more fellows also. So the network nodes I will give you right click. So we will get the boxes new, and then I can view as transmitter as RKE ECU. Just you can type RKE, that's enough now. Then give OK. Same like that you can create for body control module. Then give OK. So and then one more I have created like an instrumental cluster. So this output we can see in the instrumental cluster also. So instrumental cluster is nothing but our car dashboard, the driver side dashboard. So I can start from say as a IC, instrumental cluster. Instead of instrumental cluster, I can say as a IC. So now we have the 3 ECUs, which means 3 nodes. So for that we need to transmit some signals and receive some signals. So first we can go to signals, and then right click.
Sir, wait. After we receive text.
IC, instrumental cluster is
I see.
IC. You can take one more because as per requirement we are able to transmit signals, receive signal by different kind of ECUs also. Okay. So move to signals. So now here we are going to create the signals and then we will allocate with the ID numbers. So right click and then give new. So it is the definition of the signals. So in that we need to create a signal name log. So what the length bit we need, based on that we can change it as a length bit.
These signals we have already created. So
I just give the overview for that and then mention some of the shortcuts. So instead of going to consistency check, we will get some key points using this. So I will give the length bit 1. If the range of value 0 to 255 means you can access by the factor range of 1 and the length bit of 0 to 8. If the value is more than 255 means you can take the correct of factors with the multiplication factors. Okay. So I am using unsigned. Minimum maximum. Okay. So and then just click Control C and then you can use the Control V for copy and signal. You don't need to create again. Because the minimum and the maximum values are the same means you just rename the definition only. Because that length bit by value type these are will be saved as the same. So initially it was showing some X mark on the left side. In the signal column we can see the X mark on the left side. So log left side, unlock left side, tail left side. For me, if you are mapping that messages means it will not show. So as of now we are not getting any messages here. So it is the indication of the signals are not.
Parallelly we are doing parallelly we are doing some tests we
Oh, okay.
So when the signal is not, there is a cross mark is showing.
So this cross mark indicates the signals are not mapped by any messages. So we are able to map it by the messages only, not by directly by the ECUs with the single signals. So the indication of X mark will give us some identification for us to clear the errors. We don't need to check the again and again for the consistency. So final experiment, if you are doing any mistake, we can check it by the consistency. Shall I put messages? Yes. So in the message columns, you will create right click, new messages. Control A. I can mention as the RKE _1. ID number 4 in that. Apply and then OK. So in signals also it showing the X marker. The messages also is showing X marker. So this X mark showing that this message have no sender node and then no receiver node. So whenever we have found these X marks in the signals are not mapping on any messages. So the message is showing means it is not mapped by any transmitter and then any receivers. So just you can right click and then open the signals. Folks, add. You can add these what are the signals we need, we can add it. Okay. So now signals are mapped, going to apply. Okay. So now double click and then you can check for the layout, it will be automatically rearranged. So on that we can change it. Okay, so byte 1, byte 2, byte 3. As per the
Change to anyway. 1, 2, 3 it was actually arranged.
Yes.
Now we have changed to 16 some issue. So the change to can show anywhere, not this layout.
Yes, this byte level we can see Once you can open this signals here, this start bit is mentioned. So in the start bit, the first signal is started by the 0th bit, second signal started by the 16th bit, and third signal starts at the 8th bit, which means that analog is we have mentioned as a second byte. So analog we have mentioned as a second bit. So it says start bit. Start bit as a 0. So 0 to 7. So we just mentioned 0 as a log start bit. For analog we are using the start bit as a 8. So it is 8, it is a 16. So that is what we have mentioned the signals. Start bit as a 0, start bit as a 16, start bit as a 8. Okay.
For suppose if I am keeping one of the message in 63.
Answer 63.
What type of effect it will answer?
So we will not get any effect. So it is showing you 63, it will not affect anything. So in between that 0 to 63 bits we can locate anywhere, there is not an issue. But why I am allocating by byte 1, byte 2, byte 3 means for writing the program.
That's right.
Yeah.
So wherever you want, you can keep it here. But
Yes.
you have to remember this location.
Yes, but here if you can arrange, here means also not an issue. If you can access the byte number 8 means you will directly getting the access. But if you are allocating like now the byte 2 carries the two values. Byte 2 carries the log values and the tailgate values. For this you need to write the loop mode setup. So for that in this byte we are going to separate the bit, first bit, the second bit, the first bit for log, analog, second bit for tailgate. So it is taken more time and it is little bit complicated to normal set bit values. So that we have arranged as an individual byte and it will not affect anything. So it is not a disadvantage. It is also possible to we can work on it. Okay. So as of now we have created the signals and we have mapped by the ID number 400. So finally you have see here in the signal side we are not getting any X mark because we mapped the signals with the ID number 400 or any other IDs. But this message is only getting the X mark. So it mentioned like that it is not coming any sender node and it is not coming any receiver node. If you can clear this, that also you will defeat. Going to RK is a transmitter, so I can set the RK ECU and transmit the messages. Add ID number 400. So then click OK. So the same like that we are going to set for the BCM as a receiver, body control module. So going to check the body control module. So map as a RX signal. So don't confuse with it. Transmit means you are going for the TX messages. You are not able to send as an individual signal. You need to transmit as an identifier 400. So in the received side we can receive the signal because if anything will be received without the name of without the ID of 400 or anything. So it will come with the only ID. So that here we can directly check the signal. For example, if we can check the signal, it is comes under the message of RKU. It is showing like a RKU message. So now these three signals are in use. So I have selected link, then click OK. Yes, apply and then OK. So it is the one receiver. The one more receiver is the instrumental cluster. Parallelly, what is the output we have received with the body control module? We can see it under instrumental cluster. So that we are going for IC and then double click. We have mapped the same signal on the RX also. Map the RX. So then add individual signal message anything. We can give it and then add the. Now this lock unlock data received by both body control module and then instrumental cluster unit at the same time. So now we can check the consistency check. So now we have created a proper database for the different kind of ECUs with the 3 different signals along with one messages. So is it okay? So it is the creation of database. Now it is called as a communication matrix. So technically they can say as a communication matrix. Yes, not signals, and a database. CAN communication matrix. So CAN you can see means the option view. Going to the top left one file is there, edit, and then next one view. So going to that communication matrix. Yes. So the sample is nothing but our network name. If you have created BURT, it is showing like a BURT.
So can you repeat?
So this is called a CAN database development. Yes. CAN database development. Technically, we can say as a CAN communication matrix. So we can see this on the view point. File, edit, next view. So check the view. So the last option is the communication matrix before last. Open the communication matrix and select all and then click OK. Selected.
Take the sample here.
Yes. Okay. So the network name we have created. So it is called as a communication matrix. So what are the signals allocated by there? What are the ECUs and what are the receivers? So how we can read this means the signal of log can be transmitted by the RPA ECU and the receiver the message ID number 400 by body control module as well as the same as the instrumental cluster. Okay. So it is a CAN communication matrix. For example, I will show you one more database. I have created a really 100 signals. Yes. So this is my database. So I have already created nearly the 180 signals, 118 signals I have created along with the message IDs of 23 messages with the mapping of 28 nodes. Okay. So here we can see that view communication matrix. So this is the communication matrix for the 28 signals. So for example, so the signal of coolant temperature. So the coolant temperature is transmitted by the EMS ECU. EMS means engine management system ECU. So the ID number of 10. So here you can see that the engine ECU is the one important thing in our car. So that I am giving a very less number of ID number 10. So any work for this we need a transmission control unit chassis system that engine EMS. These are mandatory. So further based on that we will create the ID numbers that 10 and 20 based on that. So the engine ECU, the coolant temperature is transmitted by the EMS. Now we can see that it is received by
Instrumental cluster.
yes, instrumental cluster. So not we are not receiving coolant temperature, instead of that we are receiving engine speed. Okay. So engine speed is received by IC. So these are all
Part of the center, Indian coolant temperature also to the instrument cluster, right? Indian getting heated.
yes, sir. Now it is there. So based on the features, based on the OEM's requirement, we can add anything. So it is just a basic version of that values. So as the basic or what are the details we will have, that is the points I have created in this database. Okay, so this is we are going to create it now. So I will allocate 20 issues or else each of will carry 4 or 3.
We'll take all.
All these.
So after this creation of database, what is the next step?
Yes.
Can we send any signal from the transmitter to the receiver?
Yes, we will check with that on offline mode and then online mode. So online means nothing but if you transmit whether there is no get. Offline mode we will check that raw values.
Sir, the thought is close. Now shall I ask questions?
Yes.
Sir, we have done some 2 exercises. Like we have created messages, signals.
Created?
We have done some tests. We have one with the creation of database.
Yes.
From 2 exercises we have done.
Yes.
Now we have the let us say for example we have taken ECUs transmitted ECU to receiver systems. We have created some kind of signals log. Now these examples can you relate with this game framework where actually this you have so many fields there, right?
Yes. So just now we can design it. For example, I will show you. I can upload my database on TS Master. So once we have created a database, we are going to upload here what was nearly 180 signals, 23 messages, 28 nodes, everything will be shown here. Okay. So without the database, we are not able to do anything. So after getting this, we have sending some values. For example, I am going to use the transmitted node. Here I can trigger our values. For example, RKE. Yes. RKE. So here I am going to check some values. It is type some interactive generator block based on the values. We are sending the values as a value range. It is having some of the analysis settings. So now I trigger this. Now we can check it in the trace window. So this is the actually I have mentioned that trace window. So here we are going to check for the signals. So now it is showing like signal only 0101. It is showing the identifier number 120. So now we just transmitted only the ID number 120. So here we need to set some channels here. And then FPS is nothing but frames per second. So per second, how many times this message will be transmitted. So this is the advantage of using CAN protocol. So it means we are not able to lost any data. At the time of data exchange, we are not able to lost any data. So if the message transmitted for 100 times per second means definitely we are not able to lost any data. If it is lost, so within 10 milliseconds it will be recovered. So it will not give any more that much impact for that any safety purposes. Okay. So now I will transmit both the messages. So now we have transmitted the two messages. So based on that, we are going to check in the analysis. So for this non-analog delegate, now we can simulate the values. So now we don't have any real-time ECUs, but without ECUs, we are going to check our requirements. So now I am assumed so for 100 milliseconds, 100 times per time, will be executed the value 0101 continuously for checking some futures data. So if I have setting the value 1 means what's output for the BCM. So if you have set the value of 0 means what's output for the BCM. Like that we can check it. We will send it by.
This can be modeled in instant cluster. Ensure the instant cluster.
Yes, we can say check the same in instant cluster also. So just now on the create one panel.
How do you have any panel? Show that.
So just I will explain on LEDs. Later I will show you my other real-time clusters.
Not creating.
Okay, now we can see it is at the So now we can see it is at the one more ECU. Without ECU, we can check it is a real-time cluster. So now here we don't have ECU, but it is acting as a real-time ECU, which means we have connected the on the instrumental cluster. So same time parallelly it is sending the data for the BCM. At the same time it is sending the values for the instrumental cluster also. This is what we are going to testing in our CAN protocol. So now we are checking for the 10 milliseconds. So here I have transmitted the values for the.
What is the counter here, sir?
Sir.
Counter.
Message counter, sir. Whenever we are starting the analysis.
So this one we are going to do.
Yes. We need to create an instrumental cluster also. So I think. So that is the most step to work.
Actually, one request. For suppose if we are building something right now, consider that. Then first what we are going to do, that you please explain on the board.
Yes.
Maybe this is the first step you do, everyone you do it. Second step, everyone. You should treat us like a children. So we don't know anything. In fact, this idea is very much new to us.
Yes.
And we don't have anything also. Any
Yeah,
idea?
understood, sir.
That means it's not ask a question, we ask the correct question. We are going the future world directly you are showing to us. How you feel
For that,
you are going to tell this one to us. You tell this us and this one will come later, will come one by one. Then it will be useful.
for that, just as a clarification, because that camp frame format is that working on back end. We are not able to see that. That is start off framework, that acknowledgement error, CRC. I don't have any front end output for that. It will be working on back end, but whenever we found the error, at that time you will get the red color output traces here. So that is also I will show you. At that time, Sir is asking for active error, passive error. I have in that one statistics window for that active error, passive error. At the time,
Somebody will explain to you.
yes, definitely I will explain. For that, now Sir will get some idea for that. Because I don't have really front end output for that start of frame and then end of frame in between that field. But why we are creating that identifier, the DLC data field is a main concept for us. I would like to give you some understanding about that. but you can get that idea for that. Means easily you are able to access this tool. It is a very user-friendly tool. But why we are creating that ID, why we are creating the DLC, how we can arrange the layout. So that is the thing now we understood. That's the functional design. That is the CAN database. That is you understood means you are able to create a database. Means easily you can access it because based on the database only this tool will be going to work on it. So what's the timing value we can set here? But in this database, after you have created the database, I will give you an attribute definition. Just like just a single line code only. Once you enable this code only, we are able to transmit the timing of 10 milliseconds to 1000 milliseconds for that. But I am not pushing that enter in the single panel. So first we can create the database. After the database, we need to add on attribute definitions. So if we can add the definitions only, we are able to trigger the signals like that. Or others we just using a push button. Whenever we can press the button, we are able to trigger like this. Okay. So as of now, you just focusing on functional design. That is better, I think.
Sir, what will be there inside the database?
Sir, this database consists of only the CAN signals, which means the sensors values it will be detect. So based on the values, the ECU will take the decision. So decision making will be sending the output as an actuators.
As far as I know, database will store the data in the form of tables.
Yes.
So can we see the tables first? And the tables structure.
For
Okay, database.
yes, one second, sir. Please. You can please ask that one question again.
Can we see the list of tables that are available in our database?
List of tables for what?
As he's saying that every generally in database, general database field, it will be stored in terms of tables. Like this signals, rows and columns. So sorry, so can you show?
But this database not having any, it is a particular value, we need to add it not like that. For example, we are having this portal, add lots of ECUs, the electronic control units, devices add here. For example, just I will explain with the body control BCM. So in this BCM, I mentioned because all the ECUs are not necessary for all the cars. That is based on the car features only. So the increase of the electronic control units based on the car features. As of now, it is a common feature. The body control module is a common for all the car. Just I will explain. Here I explain what is the function of the control unit. This body control unit. That is everything I mentioned. Working part everything I mentioned. So the last page I have mentioned. So what are the signals we have available in this ECU? So this is what. So for example, here the CAN signal in this ECU available with the door lock, unlock signal, interior lighting control, timing signal, window control, wiper control, home control, lighting status, ignition control, trunk release, the front the trunk release signal, So these in the some of the cars there is not a crank release. We need to open with some solenoid, like we can push some rod like that. But some of them have some buttons. Whenever you press the button, the automatically the crank will be open. So based on vary of the car, it will be signals will be vary. But we can take some comments. These are the signals now available with us. Like that we can assume. So this signal will be having definitely on values. So door means definitely we are having 0 1s. So that the assumption of values we have created in the database. Okay. So in the real-time car, they are having the values transmitted by the real-time analog. Some switch values will be transmitted. So without that, with the help of database, we can simulate the values. Okay. So that is called as the software loop testing. So before the entire software, we just design the values. We can assume we have one car database. We read this system acts on real-time car. Real-time car, we can access the value of one for the door lock signal means really real-timely you can open the door like that. So that is the concept we are going to do here using the help of case master. So if you can read that all the ECUs means you will get some idea. So each of the ECUs I will give the TX and an RX number. So which means we are having the transmitter or as a body control module. This is used by instrument cluster as well as the same time driver assistance system also. So now there are some easy things for example, you can take door lock signal, go into our database here, so lock signal, you can take the lock signal, you can give the values as 0 and then 1 and then you can save it. Now you will create a message ID for it, ID number 400. ID number 400 you can using any values. As you wish, you can using any values. Because final testing I will provide my database. Okay. So for our practice purpose you can using any IDs. Okay. So afterwards the mapping purpose. Okay. So after that mapping purposes, you can using the help of this TX and then RX nodes. Here I gave the DCM node. So you can create a node as a DCM as a transmitter. You can create 2 nodes. One as an instrument cluster, another one as a driver system. So you can map it the signals to both instrument cluster and then driver system. So that is enough. So this is a CAN database.
So CAN database maximum we are using for the digital signal. Any analog signal we are using.
Yes, we are using it. So for that I am showing the transmission control module. So in this signals we are having that vehicle speed, throttle position. So engine speed will not come for the transmission dimension longer. So brake status, transmission fluid temperature, gear position. So these are all comes under transmission control module. These values will comes under up to 200. Vehicle speed you can set as
Speed only
throttle position you can set as a 0 to 100 percentage level. So you can mention as a percentage. So based on the throttle position values, you will access some.
This is small.
Yes. Brake status. So brake status also we can mention as a percentage level. Applying brake as a percentage level. So then transmission fluid temperature. That some of the time temperature values as a minus values also. So then gear position. It is a 5 shift 6 shift gears. Gear 1, 2, 3, 4, 5, and then reverse gear as a 6, neutral gear as a 7, 0. So like that you have created a signals. Here I will mention that. So what are the sensors also we use here for getting vehicle speed, we using the vehicle speed sensor. Throttle position also we are using the engine speed sensor. So brake switch, transmission fluid temperature sensor. What are the sensors they are using for that particular issue? So these are the sensors will help you to sending the data for particular issue. So I using is a transmission control module. So module and then control both are same.
Some sensors are DC fields and DC information, some sensors are PE information.
So on the DCs I will mention the particular.
So if you don't calibrate for this sensor, calibration is needed. For example,
yes,
sensor.
Yes, the calibration is so the calibration is a different department. Okay. So the calibration of sensors is the biggest level of work. So we are not going to
It's correct. If it's the car, anyone can we check for the calibration.
Yes, sir.
Suppose I purchase one car after 10 years, 15 years, also we are not doing any calibrations. Correct.
Yes, sir. But in this tool we are having the calibration options also. Just to show you. Yes, we are having the calibration managers. But I'm not specialized on calibration. So I'm just focusing on testing.
General study, we are doing calibration for meter purchase of car.
Yes.
In 4 years later, we will do for the calibration.
That is based on our performance of cars, sir.
Before giving the car, definitely you will do.
Yes,
That is what we want.
See,
That is
what
the
is the frequency of calibration of the sensor?
No.
Car is happening. So
After years,
it
later,
is
this is general working.
yes.
Otherwise, if suppose you will not do any calibration, the value is not accurate. Maybe it's a plus or minus some error.
Yes, sir. Steering wheel changes also. These kind of things.
The accuracy is not there. Without calibration means maybe the accuracy means
Definitely, sir.
because our we are having a meter, voltmeter, and not very calibration. But it's not visible. Either 220 volt, having 290, 270, it's not a big difference.
Yes. I am sure the calibration concept entirely I don't know.
Oh.
Yes, yes. So.
But generally, they are doing calibration.
Yes, definitely. Yes, yes, definitely we can do the calculations. So at the time of the service diagnostics, if we need,
15 years ago, this will
Yes.
that the range of years I don't know exactly. I don't know the range of years, but definitely we can do the calculation.
If it dust is form on the sensor, then it is also malfunction. You don't
Give
And then speak about the malfunctions. This meter which is some 5 years I calculation meters, the calculation decides for the accuracy only. But anyway it's working.
So on that. Okay, so for this transmission control unit, we have different kinds of receivers. Because the transmission control setting the engine ECU and then shifter cluster for ABS also, and then electric steering control unit also ESC. So these are all different kind of receivers. So for if we are working for the transmission control unit, we don't know this R4. So we have designed the values for the ECU. We have designed one ECU, which means we can add the code on the CAN database. So the same as well as we can receive on the TS motion control also. So on that we can further checking the requirements. So that is the user for CAN database. So as of for working car there is not an issue, but service time you mentioned we are facing some issues.
Yes.
Like at the time without database we will not get anything proper. For example, for a not running. So here I have uploaded the database. So just an example. So here I uploaded the database so that we can easily know what it is a CAN channel from, it is a RKE message like that. So if I am not upload any database and transmit some management, will not definitely not get any output like this. It is a correct thing or not. So now it shows like only ID number 120, but we don't know which ID it is. The ID number 120 is engine ID or transmission ID. So where it is transmission, where it is resumed, we don't know anything. So that is the mapping they have definitely created in the CAN database. So that is the purpose of CAN database. So before adding a feature in the ECU, for example, in our RKE we are adding that one of the new features, the search alarm. So the search alarm we say one feature. The feature they will using the help of some sensors, calibrated, they added some wiring systems, everything. But they connected to the testing tool, definitely they need a CAN database. So the database only will show you the result. For example. Here you can see it's just showing that ID number 120, it is showing the FPS, what FPS we have set here. So, but it is not showing any message name. So now we are not able to identify which message where it is transmitted. So where is the fault detection? Now it is showing the error means it is a fault detection, fault to error, fault message like that. But we don't know where the fault is detected. So which message is detected the fault like that. Now you have without this tool is able to connect with car also real-time car. So I don't have any OBD ports. If I have OBD ports means definitely we can check the real-time car also.
Okay.
Yes. So in the phase 2 I plan to purchase one OBD port also. If I have OBD ports definitely we can connect with the anyone of the car if you have provided. We can connect with the car and then we have the device, the peak device. One white color. No, that lamp. Just to get. So if we have a real-time car between actions, so it is a CAN interface. So to getting the CAN values from a car. So here now we set as OBD to the OBD port. So instead of real-time OBD, we can access this as a OBD port like that. But if we have real-time OBD, we can connect this to the OBD. Then one more end we can connect with our laptop system. So when you turn on the ignition, automatically the list of messages we can see. So around 2047 messages we are able to create now. That message is nearly 500 messages we are able to see here. But we don't know what is the message is. Okay. So we don't know what is the message is there. So for that purpose we need a CAN database. But for example, you have a Kia car, but we don't have the CAN database means we are not able to rectify the error. So that conventional data of the CAN database. So whenever you visit the Kia showroom only, we are able to service the diagnosis. So and why they are not providing means it is easy to reprogramming the ECUs also. So it is not a security for our car because now all the cars have security features. So for that they will not provide it. But if you form the ID number means you can write the camel scripting here. So we can write a scripting here, we can set the timer sample and RX sample TX, same like different hard protocols, flex ray, Ethernet, TCP, UDP, these kind of things. Yes. Yeah, writing this program, we can reprogram the ECUs. So it is easy to CAN our car. So under one more thing, we can diagnose the reprogramming comes in the diagnostic module. So in this diagnostic module, we have set which channel, CAN channel, this kind of things, some security purposes, everything. This database they mention the security key also. Like for this signal accessing, this kind of things also they mention. So based on the reprogramming of these use, so that they will not provide the conventional data. If they can provide means that the other partner competitors also will be able to develop their features. So K added on feature means they are going to develop that feature. So like some of that standardization they have not provided database for instance. Multi-network databases. Multi-network databases. Okay, so as of now we don't want to go for up to end of the class. We just create the database. So with the help of our Acharya portal, I have provided nearly 20 on ECUs here.
Okay.
So I have the access, I give the access for you all. Go to Harita Acharya portal. Go to courses here. I give the access for all the people. So on that open automotive electronics. So in this automotive, sir.
It's open, basic things is open. Means easy to understand. One small. Now, created data systems.
Yes.
I created
Yes.
So in my database, I have 3 ECUs.
Yes.
In your database, 6 ECUs.
Yes.
Then I import that ECUs to my database.
No, it's not. Because you created a different network, I created a different network. So we are not able to mention that.
If you provide that file, now this file I can share with you. From that file, I can upload this file.
You can upload on TS master, but not able to mention. You created 6, I created 4 now. But we are not able to mention like 10. Your 6 as a 6, my 4 as a 4. So, but we can add it on the TS master like.
Right now, you said that each and everyone will get one.
Yes, for I will use some practice purposes now. But at the time of enter to the TS master, I will provide a common database for you.
Okay, you will provide.
Yes, I will provide it because I have nearly 100 signals. So that is easy for our testing to get more data. So in this automobile electronics, we have the electronic control units. So just we can go with the transmission control module. Open the transmission control module. Control module. Yes, on that I mentioned in the page number 8. So for the signals we have created, and then afterwards we have page number 10 we have mentioned the TX node and then RH. Okay. So for this signals we need a values, correct? So what is the minimum value, what is the maximum value we need? So if we can use the help of a Chrome or we can take a ChatGPT, we can mention I am going to create database for the signal of Day2 speed means we need the factors, the what are the conditions we need to mention, that is giving the minimum maximum factors, offset, everything they will work. But the ChatGPT will provide for 16 bits. You can just rewrite as a length, let us say 8 factor you can change as well.
Because we have to create this.
Yes, you just created just one more ECU as of now.
How many issues?
So now we have 21 ECUs here.
One month we create, how to create that page. It's not possible. At least 2 we have to create.
So ECU you can create 5, sir. Which means here we have 5 ECUs.
Right now, the ask is
ECU you can create 4 ECU, transfer you can create 4.
we have to create 5.
Yes, 5.
5.
So 5 ECUs, message only one message.
Like same order.
Same order. But you create the signals, what are the signals I have mentioned? I think nearly 7 signals are there. 1, 2, 3, engine architecture. So 5 signals you can create. You just need to request an acknowledge message. So signal. Vehicle speed, throttle position, brake status, fluid temperature, air pressure. These 5 signals you can create.
Any 5 you have.
Okay, any 5 as your wish. Transmission control module. The overview of CAN databases. So as of now we have created the signals and then we are able to mapping from that particular messages. So mapping of messages we can setting the mapping for transmission issue and then receiver issue. Okay. So and then we have faced some issues for signal creation to signal creation and mapping from one ID to another ECUs. So just I will create one more signal now. For example, vehicle speed. Just for example, I take 8 bit and then make us a 255. Okay. So brake status. So we have one more message. TCU. So the ID number reference. So here we are going to add our signal. So vehicle speed and then brake status. So please give the importance like the arrange a label as a descending order. So if we can arrange any orders, there is not an issue. But if we can arrange like a descending orders, means we can easily occupy all the values of the bytes. So for example, so you are created 2 more signals for TCUs also, like gear position and then fluid temperatures also. So on that for gear position we are using only 3 bits of value, fluid temperature we are using 6 bits and then vehicle speed we are using up to 8 bits. So nearly it will showing like a 8, 5, again 7 like that. So if we can use like this means we are just putting that value as a empty. So whenever you are directly accessing the byte bit, there is not an issue. But when you are working along with both bytes, byte 1 and then byte 2 means at the time it is using some stored places. So it is recommended to use cover all the places like that. So that we can take as a descending order means we will reduce some of the load. So that I prefer to make it as a descending order. And it is not a mandatory thing, but it is just like a preference. Okay. So and then we need to create two more nodes. So one is a TCU. So for this receiver, we can say AC. ACM. ACC. ACC means nothing but adaptive closed control. Okay. So initially we were just mapping the from one ECU to another ECU all the signal values. For example, go to network nodes. I'm going to mapping for the transmission. So TX messages added ECU. So now the TX signals, vehicle speed, brake status are added, so it is a transmission message. So on the previously using the for ECM means we are using a direct resume signal and the all from one messages like TCU if you can give it. So all the signals from the TCU will be received here. So as of now some small changes there. So the transmitter is a single ECU but receiver is a multiple ECU for multiple signals. For example, now we are having in the TCU two signals, vehicle speed and then brake status. So the vehicle speed we need to give it for the ABS and then vehicle speed we can give it for the instrument cluster and then engine control module and then brake status we just give it to only for ABS. So now we can see this in this node. Yes. So now the ECM received both vehicle speed and then brake status, but we don't want the brake status for this ECM. So what we are going to do means, I just do it again. I remove this mapping.
So transmitter only sending information. Transmitter means
just only sending the values,
not information.
not able to receive it because we are not mapping as a receiver. But this ECU is able to receive any kind of other signals. If we map the means, we can receive other signals also. For example, so now TCU having the two signals. So the vehicle speed I need to give it to the ECM and then IC, instrumental cluster. Same time for engine control module, as the same values we need to see in the instrumental cluster. So the brake status we need to give only for ABS. So here it is act as a one transmitter. It is received by 3 receivers. One is the engine control module, one is the instrumental cluster, one more is the ABS. So ABS for particular signal, brake status, and then the vehicle speed is for 2 ECUs, instrumental cluster and then engine control module. So that is the requirement I have previously mentioned in our code. So now we can do for instead of ACC I can mention ABS. Okay. For this ABS ECU we are going to receive the signal and individual signals. We can add only brake status. So now we can add this means it is comes from the TCU message only. So the identifier will not change, the receiver transmitter will not change. So the receiver just taken the ID number of converter and taken the only accessing of that what is the starting bit for the brake status. For example, 9th bit. 9th bit is only will be taken. Okay. So now it is accessing only brake status only. Okay. So next we can give it for the ECM. So received by only vehicle speed. Okay. So on the same we can give it for IC also. Okay. So now we can see in our communication matrix view. So here you can see that previously we did lock tailgate unlock. So it is transmitted by RKECU. It is no need to specify any other ECUs. It's just only body control module. So we can directly transmitted received by the body control module ECU. But in this vehicle speed, it is transmitted by transmission control unit and received by instrumental cluster at the ECM. And the same one brake state is also there. The brake state is also transmitted by transmission control unit, but it is received by another ECU. It is a ABS. Okay, so it is a different kind of receivers. That is what we have mentioned in our flow chart initial class. That introduction slide we have able to receive by all the receivers. What we mentioned. So that time we are able to receive a different kind of receivers. If you are not giving the any receivers, it will be received by all the nodes. So at the time of writing program, we have one more options. We can receive any messages. The option is there. So on the time we can click the any messages means we can receive any messages. For if we mapping means we need to mention the ID name. So that's the difference between that. Okay. So for whatever we have developed any features, we need to map on it because we need to transmit some values at the range of this one to this one, at the time range of this time to this time. We need to map it. So the same values and the same timing range, they will give the get the acknowledgement from receiver. So that is called as a functional designing in that verification validation method.
Here PC is only transmitting and the AC is not able to receive the signals.
Receive, able to receive. For example, I will show you one more. I just create engine RPM. I just mentioned RPM is at 255 only, not like thousands. For example, I took only 255. So going to messages, for the signal we need a message ID. So that again I have created an ID for the engine control module. ECM underscore one. So the ID number okay, and then signals we have added that engine RPM model. So what are signals we have created? We need to map at least any one of the message. So for understanding, I am creating just a new message for engine. So in this layout, we have added we have given only one DLC because we are carrying only one signal. So now we are creating. We are already having the engine control model mode. So it is going to transmit it. So transmit messages add. So transmission ID is 300. Okay. So the TX signal is the engine RPM. It is the receiving vehicle speed also. It is a previous mapping. So receiving. Okay. So right. So now our question is that we are able to receive by TCU also. So going to TCU, map the RX signal, add individual signal, and we can call ECM on engine RPM. Right? Okay. So now we can check in our communication matrix. Here you can see the vehicle speed is transmitted by TCM, received by other two ECUs. Same like the engine RPM is transmitted by other ECU but received by TCU. So this ECU is able to transmit the values and then receive the values also. So that is no issues for that. We can transmit and receive at the same time. So based on that identifies. Okay, so actually this is the overview of this CAN database. So we are able to.
Actually, you started with one node can send one signal can send by two nodes.
One signal can
Send by two signals.
send by two nodes.
By two nodes.
Yes. So the RK already is sending the signal of lock tailgate unlock. We can check it with the TCU. Just example. So it's not a real time now. Just example, I added one signal. So same signal we have added here. What is this? That lock. We have added the layout. We have added. Because we are using the 3 signal here. So previously we were using the 2, so that 2 DLC, now we are using 3 dimensions. So now this value is also going to receive by IC. We can give it as a IC. So now it is automatically, we can check it here. Transmitted signals from TCU, vehicle speed, brake status, and then lock. Now we added the lock now. So previously entered the entire message, so that automatically the lock also will engage with this. So now we can check it IC. IC can receive the added signal from lock. So here you can see 2 locks are there, RKU1 and then TCU1. So 2 signals values can be generated for different kind of messages. So it is having a different message ID, it is having a different message ID. For example, now our car having that ultrasonic sensor for reverse parking system. So they are using only for example 2 sensors they are using in the back side. So the sensors values will be getted, and then you can give it to the separate ECUs. So okay, so the same value can be taken and separate by ECUs. So just a minute. So I can select the lock TCU_1, which means I am not selecting RK message. I am just selecting the TCU message. Okay.